page 27. So they're going to give us, and they want to know the 6th, the 7th, and the 12th, and then they're going to want to know the nth term. Sometimes it's easy to find the nth term. So you have 4, 7, 10, 13, and 16. Well, on the nth term, what you can see here is that if you take 3 times the term and you add 1 to it, 3 times 2, add 1, 3 times 3, add 1, 3 times 4, add 1, 3 times the 5, and add 1. That'll give you each one of those numbers. So then this 6th term, if you took 3 times 6, 18, and add 1, it'd make it 19. And 3 times 7, 21, gives you 22. And 3 times the 30, 12 is 36, and add 1 is 37. So the nth term is 3n plus 1. The B says 0, 3, well, let's see. I got it. 1, 2, 3, 4, 5. 15, and 24. Then they want 6, 7, 12. Can you see anything that what's that? Okay, and that would be okay. It's the general term is n squared minus 1. That's what those all fit. So then 6 would be 36 minus 1 is 35. 49 minus 1 is 48. That's 144 minus 1 is 143. Okay, the next one, 16C. For 1, 2, 3. So this is 1, 4, 8. And then the nth term. These are
It's 2, N minus 1 is the power.
Okay, very good. So then this is going to be 32, right? 64, and then the 12th. Let's see. I don't know.
What's 2 to the 11th power? Who's got the calculator?
It'd be 2 to the 6th and 2 to the 5th. So this would be, this is 2 to the 6th and this is 2 to the 5th. So it's 32 times 64. Okay.
I forgot about that rule.
Yeah. Sum of your exponents. Okay, so D dang it, I forgot to put okay, so negative n over n plus 1. Okay, so then this is going to be a negative 6 over 7. This is a negative 7 over 8. And this is a negative 12 over 13. And that's your general term. All right, 18 says 6 cities, A, B, C, D, E, F, are located as shown next. If bike paths are constructed so that each pair of cities would be connected by a direct path, how many paths are there? What? Okay. 15 paths would be correct.
I got that too, but how do you do that without actually drawing it out? Is there a formula?
Combinatorics.
Say it again, Ryan?
Combinatorics. Basically, you're just asking, you're counting the number of different paths. And since one is more than one, you exclude multiples, you use the combinatorics formula, which is n factorial divided by r factorial multiplied by n minus r factorial. R is 2 is just taking a path between 2 cities. So 6 factorial over 2 factorial multiplied by 4 factorial. 6 minus 2 is 4 factorial. So that would be 6 over 5 is 30 divided by 2, so that is 15.
Excellent. Excellent.
I guess I don't know that formula, so I wouldn't know how.
It's, yes.
But you, yeah. In what?
It's a probability statistics topic.
Okay. You know, probably what you do is try to figure out, you know, like counting and get a sequence set up. If you didn't know that particular. But 15 was the answer. Okay. Okay, you need, this one is how many different paths are there to get from work to the bank. So this is the bank. And it's 6 block, their instructions say need to walk from work the bank and a distance of 6 blocks. So you gotta do different routes in 6 block increments. So, I mean, I'm not sure how you would do it, except you would just list it out. You just make different routes. And if you, one way you could do it is if you just put on each one of these intersections a number. Let's see. 6. Do 7. And then list out going to what corners, one at a time. Like the first one would be if you went along the bottom and then up, you'd go 0, 1, 2, 3, 4, 5, and 6. And you just list it out. Then you could go 0, 1, 2, you could go up to 15, then go back over to 4, 5, 6. And you just have to make different routes. And I don't know how to do it except to list it out that way.
Professor, you can't get from 2 to 14.
Yeah, I went the wrong thing. You go 2, 15, then to 14, then to 5, 6. Then go 15, 14, 11, and 6. So that would you know 0, 1, 2. That would be 0, 1, 3 and 0, 1, 2 would be taken care of at that point. And then you would have to go. You'd go 0, 1. You already got to the 2, so then you'd go up to the 13, then go to the 15, and then to 4, and then to 5, and then to 6. And go 0, 1, go up to 13, and then go to 15, then go up to 14, then go over to 5, and then go 6.
That's what the question is asking for a 6-block pad.
Yeah.
So anything over 6 would be not acceptable.
What? Yeah,
Question itself wants 6-block pads.
yeah,
So if you go over 6
Yeah.
blocks, it's not acceptable.
that's right. Yeah. So you go 0, 1, 13, 15, 11, say 14, 11. 11 and 6. Now you've exhausted everything going from 0 to 1 to 13 and over to 15. So now you're going to have to go 0, 0 1s are all done. So 0, 7. And then you can go to 13. Then you can go over to 15, and then to 4, then to 5, then to 6. And you go 0, 7, 13, 15, then you have to go up to 14, then over to 5, and then 6. 7, 13, 15, 14, and 11, and then 6. Now you got everything taken care of. 0, 7 on the part that don't have that block, but you got 0, 7, and then go over to 13, then go up to 12, 10, 11, and 6. And you can't go in 0, 7 and then going across, you're done with that. So now you're going to have to go 0, 7, 8, then go over to 12. And I think that's up to 10. And then 11, 6. This thing here. Zero, 7, 8. Now you can't go to 12, so you're going to go to. Must have missed one. 9, 10, 11, 6. There's 14 of them. I missed one. 12. Which one did I miss? This is the outside one. 12. I missed one. There's 14 of them. But that's the only way I know that you can get it done. Okay, that next group of problems, I'm not gonna go back and try to find it. This involves these Fibonacci sequence. And what it is, you're just summing the previous two elements. So that would be 2, and then you'd have 3, then you'd have 5, then you'd have 8. You're just summing the previous two elements. 8, 13, and then 21. And it just keeps going. So that is Fibonacci sequence. So in 22 it says determine the missing numbers. So he had in A he had 2, 5, 7, 12. The next 3. So then what would you have? 19, right? And then 31. Did I add? A lot of times I can't add. 50. Did I add right? This one is 1, 7, 20, and 8. So then the first blank would be what? 6. And this blank right here would be 13, right? And then the next one is going to be 33, the sum of the previous two. Let's see. This is 3, 18, and this one. So how are you going to approach that? What? Okay, see.
And the third part of the sequence is just plus x.
Okay.
Some of those should be equal to negative 2, so those
So you take x plus 3 plus x plus x.
So that's equal to 19.
So then you get 2x equals 16. X is going to equal 8. So then this is 8. And that makes this one 11. Makes this one 30. Okay. So next one is 10. Blank.
This requires an extra set of entities. But I can go ahead and give you what I found, which is the second number in the sequence is 13.
Okay, you could call the second, that one there,
Plus 10.
well, it's,
Just x.
you could call that one x, excuse me. You could call this one x, and then this one's x plus 10, right?
Yes. Hold on a second. 95 is the last part of the sequence. 94 eventually. Yes.
So then this would be x plus 10, wouldn't it? And then the 95 would be x plus 10 plus 2x plus 10, wouldn't it?
Well, I think you miswrote the problem there because there are four spaces.
Oh, four spaces. Okay. So then there's another one here, and then there's a 95. And then that's it. Okay. So in essence, this third one is going to be 2x plus 10, right? And that fourth one is going to be, that's 3x plus 20, isn't it? So then 2x, then you could say the 2x plus 10 plus the 3x plus 20 should equal 95. Okay, everybody laid it out right? This one is x. This one is x plus 10 because it's the previous two numbers. Then this one's a previous two, which is x plus 10, which is 2x plus 10. Then this one is a previous two, which is this one, and that's 3x plus 20. Then the 95 is going to be the 2x plus 10 plus 3x plus 20. So then I get 4x plus 30 equals 95. 4x is equal to 65. Well, this don't make it.
5x or 5x.
5x. Thank you, Lord. And it's x is equal to 13. It's 13. And this, we can just go ahead and add it up, right? 23. Previous 2 is going to be 36. Previous 2 is going to be 50.
It's a mistake. Oh, no, it's
Did
not
I do it right?
my mistake.
And the previous 2 is 95, and it works out. All right, the next one. Get this.
Preston, could you go back one more for just 1 second?
To this one here.
Yes, please. So 5x was for the very last one. Okay. Thanks.
Yeah. Okay. We want to know how many triangles of all sizes and shapes are there in the picture. And the only way that I can think of it is to do it. Or maybe I should let you tell me what your strategy would be. can think of is just go around on those points and figure it out. They want triangles, right?
Yes.
Triangles. So you go 1, and then you could go 2, and you could go 3, and then you could go down here for 4. And then you could go 5, and then 6. Now, using A as a vertex, is there any other ones that you can make? So A is a vertex. 6. Is there any more? I mean, you see any more triangles? Then I'm going to do B. And what, being because I used the color, any triangle like the one that goes B, A, and down and back, that would be a duplication. You just don't want to recolor a line. So you could go here to there, down and back. Now you can't make any of those other shorter ones. That's the first one you can make. Then you could go B and go down here and come back. That would be 2. And then you could come down here, go down here, and go back. That triangle had not been made. You could go down to here and come across. By the way, what am I on? 4? And then you could do the one that comes down there. That's 5.
Professor, I get more than 6 with A as a vertex.
Yeah, I got 7.
You got 7. Which one did you get that?
We didn't get the one, the lines all to the top.
All 3 at the top.
6, 7, 8. I get 9 from A.
Okay. What?
Is there 28 triangles total?
There's 35.
Five.
You,
I think we should get some, there should be some for each place there, right? Or 5.
but only some of them, you can't duplicate them. Once you got one, you can't use it in the next vertex.
I get definitely 9 from A.
Okay. So I'm not going to go through and try to do it. It's not something that I know a method to do it, other than list them out. I don't know any method that you would use. I think you just got to list them out. And if you got 9, if you can figure out where 9, then you go to the next vertex, but you cannot duplicate a triangle.
9 should be right. Well, we use 1, it's not really
But like the professor says, it's not going to be 9 for each vertex.
Right.
Because then, you're duplicating stuff.
we use
It's
1.
like you said, you have to get your pencil out,
Yeah.
your colored pencils, and
Yeah. If in fact there's just one less, as you go around, I guess then if you can verify that, but you can't duplicate it. You cannot duplicate a triangle. And probably in order to make sure you don't duplicate a triangle, you probably going to have to make 1, 2, 3, 4, 5 different ones, and then draw your lines.
name every additional intersection.
Yeah.
And then you have to draw right out each triangle with its 3 vertices.
Well, I'm not gonna give you a problem like that, I tell you on the test, because I don't know that there is a pattern that you can come up with. Okay. 26. It says how many squares will be in the 10th set of squares if in the following sequence. So we got 1, 2, 3. So we have 1 in the first one. Then we have 3. Then we have 5. We want to look at the fourth one. It,
$19?
okay, 26. 19 would be right. So what did you use for a formula?
I just drew one out, now I'm thinking ahead. How about 2n minus 1?
That'd be right. Because every time what they're doing is they're putting 2 more on the bottom and 1 up on the top, right? It's, when you're drawing it, they're putting 1 more up here, and then they're always putting 2 more up this way. So they're always adding 3. Hmm? How does that makes this not right? Or this number's not right. Because they've added 3, so this has got to be 6.
I think you're
Three.
looking at 25.
There was 7. What's that?
I think you're looking at question 25.
Am I looking at the wrong one?
Yes.
Oh, they're just adding 1 block on each side.
Yes.
Yeah, okay. Thank you. So then this one is 5. So they're just adding 2 every time. So every time, what are they doing? Adding.
You just added 4 extra squares on each one.
They're adding 5 every time, aren't they?
Oh, yeah, they're in 5.
So this is a +5, and then the next one's going to be a +5. You're starting out with 3, 6, 7. So you put 7. So then you're going to go 12. And you're going to go 17. 1, 2, in terms of the sequence. 2, 3. And they just keep adding 5 every time, right? Is that right? So you start out with 7 and then you go 2 minus 1 times 5, right? I mean, n minus 1. Because the second one would be 1 times 5, the third one would be 2 times 5, and 3 times 5. Then if you multiply that out, then you'd get 5n plus 2. And then the 10th one then, 2 times 10 plus 2. 2 should be. Okay. So 30. Oh dear. I'll just, there's 1, 2, and 3. So there's 3, 6, there's 8, right? And on 2, 4, 8, 9, 10, 11, 12. There's 12. And 3, 5, 10, and 6. 16, is that right? Well, then apparently there's a common difference here that we're just adding 4, right? So if we start at 8 and we add n minus 1 times 4, right? Second one, so that's 8, 4n minus 4, so it should be 4n plus 4. Does that work? That would make the 10th one 4 times 10 plus 4, 44. Because as long as they go up by a common that you can just go plus, it's not too hard. A 3 by 3 by 3 cube was painted on all sides, then cut apart into 27 1 by 1 cubes. Okay, and it says, no faces painted. Well, right buried in the middle of that stack is one cube. Right, one cube. No face.
Professor, did you not do 32?
I didn't do 32. And then, if you're talking, let's see, look at one face, there's 6 of them. It'd be these, it'd be like this one, down underneath one, that's 4. Then there's one here, one on the back side, that's 6. 2 faces. 2 faces, there's gonna be 12. They gotta be like this corner one, 2, 3, 4, there. Then there's 5, 6, 7, 8. And then there's 9, 10, 11, and 12. So there's 12 of those. And then 3 faces. There's the corner ones, right? 1, 2, 3, 4, 5, 6. There's got to be 4 on the bottom and 4 on the top. There's 8 of them, right? I'll just tell you, 36 cannot be done, and that'll be the end of. We'll start chapter 2 next time. But 36 is not possible to do what they want to do. You can't make 2 cubes together and make that happen. So that's it.